Greetings, Sergio and Megan. This is Dr. Gomez. This is the video for your next to last lab. And you can see here I've got the Excel template brought up. And it's not online number 6. It's Converging Lens Lab. Yeah, so this deals with lenses, and you've got the template. And you'll see there are 3 sheets. Um, and the first 2 sheets, we're looking at sheet 1. It's a converging lens. Sheet 2 is a is another converging lens, and then sheet 3, as you can guess, is a diverging lens. So you're just doing the same thing 3 times, just for 2 converging lenses and 1 diverging lens. So let's go back to sheet 1. So here's the link to the simulation. Okay, we'll click on that. And it comes up with geometric optics, and you want to, of course, hit play. And then we don't want mirror, we want lens. And okay, you can see here. Now, right now we have a converging lens. Now, notice, according to the template, we want to set the diameter to be 0.95 meters. We want the radius of curvature to be 0.4, and we want the index of refraction to be 1.55. We want the radius of curvature, the diameter to be 0.95. We want the radius of curvature to be 0.4, and we want the index of refraction to be 1.55. So let me go ahead and so we'll go back to the simulation. And let's do principal rays down here. Now remember, I want the radius of curvature to be 0.4 or 40 centimeters. We could leave everything in centimeters. I don't know why I converted it to meters, but it doesn't matter. So a radius of curvature of 40 centimeters would be 0.4 meters. We want the diameter to be 0.95 meters or 95 centimeters. Yeah, again, I don't know why I converted to meters. It doesn't matter. But there we go. See diameter. And the index of refraction, what did I say, 1.55. Okay. And now you can see here's your object, and you can adjust your object distance, and you can see on the other side of the lens is the image. Well, here you have your ruler. You can bring your ruler down so you can set your DO and your DI. Remember, everything's measured right to the center of the lens. For now, I'm just going to put 100 there, but we can move the ruler however we want. Now, for the object, you could use the pencil if you want, and just make sure that the eraser is touching the principal axis. I guess we could do labels here. Yeah, there we go. So we've got everything. Now notice, let's go back to the template. And so we've got, and then for sheet 2, you're doing it for a converging lens again, just the same diameter, but a different radius of curvature and a different index of refraction. And we'll get to diverging in a second. So now notice, I've set your DOs for you. So you want to set the DO as 50, 60, 70, and increments of 10 up to 120. And then you're going to, so let's go ahead and let's just set the DO at 50. A little bit tedious, but let's go back to the simulation. I'm going to put the end of the ruler right there. Well, actually, I'm going to put 100 just to make it a little bit easier. Right there. Let me pause this. There we go. And now initially I want my DO to be 50. So I'm going to take the pencil and set it right here at 50. You see that? Because remember, that's 100. That's, or we'll go on, that's 10, 20, 30, 40, 50. So that's my DO. Now notice my DI is right here. And we're doing it, I guess you could do it to the front of the pencil, or the back of the pencil or the middle. I was doing it at the middle. Maybe let me do it to the front. See how I've set the front of the pencil to be right there at 50, and now I want to measure to the front of the pencil here. And let me zoom in a little bit. And now remember 100 here, so this is that's 20, 40, 60, 80, 100, and it looks like it's 100, not 110. It looks like it's 108 because I'm going to the front of the pencil. I think that should be right. Or we could do probably more accurate. Let's do middle to middle. I think that might be a bit more accurate. I'm going to do the middle of the pencil and then right to the, yeah. So right there I'm at 50, and this is again, so that's 100, 120, 130, and it looks like about 132, 4, about 136. I'm estimating the middle of the pencil, right about 136 or 137. So let me go ahead and type that in. And then, uh, and now notice it updated the focal length. It said focal length equation. Now the focal length from the simulation, well, remember, the focal length is equal to, let me pause it for 1 second. Now, if you go to the simulation, remember here's your focal point. And so your focal length is the distance from the lens to the focal point. So notice it's 10, 20, 30, and it looks like 2, 4, it looks like 36. So according to the simulation, the focal length is 36. So let me go ahead and that's not going to change. And then watch what happens to the percent difference. Okay, then you can go ahead and just copy these down because that's not going to change. Now let's go ahead and let's now set the DO to 60. Let's move it 10 centimeters farther away. So, and again, I'm going to do the middle of the pencil. So right there. Looks like, yep. And then now it looks like my DI is again 80, 90 to about 94. That's 90, then 2, 4. So 94. So again, a little bit tedious, but not bad. So I'm going to do my DI is 94. And now watch what happens to columns E and F. See that? And then just keep going. And what we're doing is we're calculating the focal length using the thin lens equation. That's what uh, this column is. See focal length equation. And it's entered in Excel for you. And then, of course, the focal length from the simulation, that doesn't change. That's the focal point there. Notice no matter what, in either side, it's what, about 36. Again, that's 20, 30, 2, 4, 6. Yeah. And so then you go ahead, set your DO to 70, 80, go to 120. All right. Then for sheet 2, you're doing the same thing. Just keep the diameter the same. Change the radius of curvature. Make it 50 instead of 40. And then we change the index of refraction. Yeah, make it 1.35. Okay. And then we'll leave the diameter the same. And then for sheet 2, we're starting with an object distance of 110. So let's go ahead and do that. So let's go to 110. So I'm going to put it right there, and then I'm going to take and right there. I was trying the middle of the pencil. Right there. And so, oh, actually, it's not quite. A little bit tedious, but you get the hang of it. There we go. That's see the ruler 110 is right at the center of of the ruler, and I'm going to take the middle of the pencil and set it right at the beginning. See, so that's my DO is 110, and then it's a little bit tedious. Now we have to go get the image distance. So I'm going to move the ruler over. Oops, whoa, whoa, whoa. There we go. And it looks like I'm at that's 200 and then 210 about looks like 208. We'll say 208. Let me just two 200 4 maybe 206. So oh, and here for when I change the parameters, I forgot. Notice here the focal length. Remember those that's the focal point. Here the focal length is 60, 70, about 72. So I'm gonna go ahead and enter that in. I forgot about that. So for the second one, the focal length is 72, and that's not going to change. And then I can go ahead and copy this down. And now let me go ahead, see now let me set my DO to 120. So I'm going to put, it's a little bit tedious, but there I'm at 120. I'm just going to move to the beginning of the ruler. I want the center of the pencil, that center dot. So my DO is 120. See, now let me get my DI. My DI is, um, let's see, 182, about 184 for my DI. So we go back again, a little bit tedious, but not too bad. Let's say 184. Now I'm going to click outside here. See? Oh, the percent difference. We can a negative. We might want to add an absolute here. I'll do ABS, and then see if that. Then a parenthesis, left parenthesis, space, and then right parenthesis. It doesn't really matter, but we like to, and then copy that down. There. And then you get the idea. Then set your DO to 130 and then get your DI so that set your DO to 130. So move the ruler so 130 is right at the center. Right there. And then move the pencil. Again, I think it's best to do the center of the pencil. See those three dots there? Just do the center dot as best you can. And then, again, move the ruler, get your DI. Again, a little bit tedious, but nothing bad. So that's the so sheets 1 and 2 are the converging lens, and then sheet 3 is the diverging lens. So let's go ahead. Let's go back to the simulation and see right here diverging lens. Okay, then I told you in the template we want to set the diameter to be 1.2 or 120 centimeters for the diameter. So 120. My mouse is acting up a little bit. So 120. I wanted the n to be 1.25. And then I want the radius of curvature to be 0.5 meters or 50 centimeters, which it is. Everything looks good. Then now again the focal length. First, let's get the focal length. In this case, it's get this ruler right here. Looks like the focal length is 100. Okay, so we'll go ahead and we'll get that entered into the template. Oh well, minus 100 because it's a diverging lens. It's already there. And then set your DO. Now you're going closer. Start at 120, then 110. And then just remember again, focal length for a diverging lens is negative. And then let's do 120. Let's just see if it actually works, and we'll finish this video. So I'm going to go back to 120. Again, this part's a little bit tedious, but so here's the pencil at 120. My image, and remember, you just have to be careful. The image is 10, 20, 30, 40, 50, to about 54. But remember, it's negative because it's a virtual image. So let's go ahead and do that. So it's negative 54. Let's click outside. Look at that. Perfect. And then just go ahead and do 110. So you get the idea. So that's the lens lab, both converging and diverging. Let me go ahead and save this video and get everything posted.